only synchronizing. When the segment of code, that is a critical section, it is being used by different process, then we want to give some synchronization mechanisms, and also the process needs to be entered in a critical section at a time only one process. Okay, we need to set the criteria for the process. Process itself cannot synchronize and the process itself cannot organize themselves to make use of the critical section. Okay, so that what we should do, we can have some hardware support, or otherwise we can have some software instructions to stop the process, to stop the number of process to enter into the critical section, so that we let only one process at a time will be entered into a critical section. Okay, so it can be done by use of software and also by use of hardware. Okay, hardware mechanism follows simply interrupting the process. Okay, through some what hardware interrupts are there, and through that we can interrupt the process, and it is what efficient policy to be followed. So stopping the process for a longer time by hardware is not supported. Okay, so that we go for interrupting the process, that is not interrupting, synchronizing the process through the software instructions. Okay, so software instructions in variables. Through the in producer consumer problem also, we have used the variables, and let the variables like flag variable or counter variable, let the variable set the criteria, and also the variable is used to stop another process using the shared area or shared variable. Okay, so here in producer consumer problem, we finally come to a conclusion that if our code is correct, even though our coding using counter variables and other variable is correct, when it is executing, it gives the race condition. It gives the problem of race condition. Okay, நம்மளோட கோடிங் பார்ட் கரெக்டா இருந்தாலும் அது மெஷின் லாங்குவேஜ்ல எக்ஸிக்யூட் ஆகும்போது we are not expecting the same outcome what we have done with high level language instructions. Okay, so it execute ஆகும்போது we should not get 6 and 4 actually. Okay, so it leads to wrong it's the wrong result which is stored in a particular variable called count. Okay, so in the count variable the value it's not executed properly. Okay, so this is the race condition. We cannot, race condition is nothing but the process executes in some order, and also the result can expect in that order only. Okay, it's not giving the desired result. That is the race condition. So we can provide a solution to this problem, and also we can set criteria, mutual exclusion should be achieved. Okay, so to overcome from the critical section problem, we need to have some criteria. Okay. So these are the 3 criteria. That is, if we are providing the solution for these 3, then we can say it is synchronization is achieved. Okay, so mutual exclusion tells you at least, only one process should enter into critical section at a time. Okay, a critical section is nothing but only one process can execute the segment of code in the critical section. Okay, now later ஒரு எக்ஸாம்பிள் சொல்றேன். டேட்டாபேஸ் டேபிள்ல அப்டேட் பண்ணும்போது எப்படி அப்டேட் ஆகுது, 2 ப்ராசஸ் அட் a டைம் அப்டேட் பண்ணும்போது அந்த டிஃபிகல்ட்டி என்ன இருக்கு அப்படிங்கிறது நான் சொல்றேன். So Peterson solution. Peterson algorithm gives some solution to critical section problem. Okay, same thing, use of some variables. Okay, so here I just want to tell you about the algorithm again. This is the actually this is the algorithm which is provided by Peterson. Okay, Peterson provided three types of algorithms. Okay, and this is the best algorithm which satisfies all the conditions we have listed in the previous slide. Okay, so this algorithm ensures mutual inclusion, and also it provides progressing, and also it gives the bounded weighting. So these 3 conditions is met, and also the critical section problem is somehow tackled by using this algorithm. See here, flag of I is equal to true, turn equal to j, and here I எப்படி செட் பண்ணாங்க எப்படி கொடுத்துருக்காங்கன்றத So and turn variable, flag variable. These two variables here we need to highlight. Turn variable is used to predict which process takes its turn. Okay, and the flag variable is set whether the process is request for the critical section or not. Okay, so these two variables are used here to provide the solution for critical section. So as I said, we have three sections. Okay, one is entry section and another one is exit section and another one is remainder section. When the process is enters into the critical section, it should go through entry section. Okay, entry section gives some criteria, gives some conditions. Okay, after satisfying that condition only the process can enter into the critical section. Okay, and after complete the job in critical section, it can execute the remainder section. That is the code which is in pending. Okay, will be executed by the process, and after that exit section is there. Even for exiting, even for coming out of the critical section, we need to set some condition. That is called exit section. That is exit criteria, you can say. Okay, so the condition will be checked when the process enters into critical section, and also the process coming out, when the process coming out of the critical section. Okay, so these three sections are there in critical section. Assumption, we just assume that a variable can only have one value, never between values. So that is the memory location. So the memory location is this. Okay, so the memory location can hold only one value. This is the assumption we have given here. Okay, so analyzing the problem, you just keep yourself that is memory location is there and only one value can be stored in the memory at that time. If process A and B write the value to the same memory location at the same time, either the value from A or the value from B will be returned rather than some scrambling of this. Okay, so what the problem, again they have given different definition of the problem, same critical section problem. Okay, so memory location is there, and in that memory location it can hold only one value at a time. Okay, so number of process can be there in the system, and but only one process at a time give a value to memory. Okay, so because the memory can hold only one value, this is the assumption given here. Okay, so that if process A stores the value in memory and also process B stores the value in memory at the same time, any one of the values should be updated in the memory, right? Okay, instead of getting some other garbage values, it should get A value or otherwise B process value. Okay, so it is the expected result we can expect in the memory location. Okay, it should not lead to some what is that, garbage value. Now A வும் அதே டைம்ல அப்டேட் பண்ணும்போது B வும் அப்டேட் பண்ணுச்சுன்னா அந்த மெமரி லொகேஷன்ல என்ன வேல்யூ இருக்கும், என்ன வேல்யூ இருக்கணும்னா either A or B வேல்யூவோட இருக்கணும். ஓகே, B ப்ரொவைட் பண்ற வேல்யூவா இருக்கணும். அது இல்லாம garbage values எதுவும் அங்க இருக்க கூடாது. ஓகே, so this is that. So to satisfy this you can go for Peterson algorithm. So this is the critical section problem actually. Okay, critical section is what here. Yes. What is the critical section here? Memory location is the critical section. Okay, please keep it in your mind. Critical section is the one which is shareable. Okay, here the memory location is shared by different processes, not the value. Okay, not the variables provided by process A and process B. Okay, it is the memory location called critical section. Okay, எது வந்து ஷேர் பண்ண முடியுதோ அததான் நம்ம critical section அப்படினு சொல்லுவோம். Okay, so if I have one apple, okay, I want to give that apple to 5. Okay, at that time I cannot break ஒரே ஒரு இந்த இதுல வந்து என்னால அத வந்து டிவைட் பண்ணி கொடுக்க முடியாது. So that apple is called as critical section. Okay, அதை எப்படி ஷேர் பண்ணுது, நிறைய அதை எப்படி ஷேர் பண்றோம் அப்படின்றது தான் ப்ராப்ளம். அந்த ஆர்டர் என்ன வருது, எப்படி சிம்பிளைஸ் பண்றது. Okay, so this is the problem actually. Peterson algorithm. A simple algorithm that So resource is nothing, resource critical section in the it is equal to memory location here. இந்த ஒரு resource share பண்றாங்க. என்ன resource அது? Memory location. Okay, and does not require any special hardware. It uses busy waiting. Okay, what is the actual logic used in C++ algorithm is, let if any other process if already the process is in memory, it should not let other process come into the memory. So it is following the logic of let other process keeps in waiting. Okay, until the process which is in memory gets complete. Okay, so this is the logic here actually. So logic is busy waiting. Okay, that is still locked. Right? Next. Yes, this is the algorithm. Repeat until false, and flag of y is equal to true, turn equal to j, and flag of j and turn is equal to x. If I read this, you cannot understand. I will show you the working steps. All tab solution. Yes. So initially, let me see. Process 0 and process 1 is there. Okay, in the algorithm நம்ம compare பண்ணிக்கலாம். Process 0 initially have the value I equal to 0 and j equal to 1, and process 1 value should be set as 1 0 for ij variables. Okay, so this is the entry condition. நான் provide பண்ற first condition is this. Okay, so process 0 and process 1 takes I, j value respectively. Okay, I value is 0, j value equal to 1, and here I value equal to 1 and j equal to 0. When process 0 is in request for the critical section. Okay, first we have two process 0 and process 1. Right? So first the process 0 is getting into the critical section. Okay, so here flag of 0 equal to true. Can you put the algorithm all type of algorithm? இந்த algorithm note பண்ணி